Hello, and thanks for coming to my talk about assessing critical thinking. The title of the talk is Assessing Critical Thinking and Preparing the Next Generation of Creative and Effective Problem Solvers, which is a fairly general title. And what I'd like to do is during the course of our time together this afternoon, I'd like to talk more specifically about what critical thinking is and how we may go about assessing it. But let me just say that our motivation, our background really is from biomedical sciences, and a lot of what we try to do at Cognitive Learning Systems is to bring to bear some of the research in neurosciences and look for ways in which advances in that field can augment or work in conjunction with classroom practices to improve K-12 education and even beyond. Interestingly, if we talk about critical thinking, this is not a topic that I have talked a lot about. It's not a topic that any of you have heard me lecture on before, but I decided that it was an important topic because we talk about it so often, and we talk about how important critical thinking is for our students, how we want to, a mission of STEM education in general is to prepare our students to be critical thinkers. So when we're talking about critical thinking, obviously we're talking about a function of the brain. So it's only natural that we would want to turn and see what neuroscience has to tell us about critical thinking. And so that's sort of what I'm trying to do here. I'm going to be jumping back and forth from neuroscience topics to educational practice types of topics, classroom practice, and ultimately, this entire talk is going to move more from discussing scientific backgrounds and neuroscience underpinnings towards more application in the classroom. So stick with me, and I hope that we'll learn a lot together. Interestingly, I think that when we think of critical thinking, regardless of how important we say that it is, it's quite different than a lot of the other initiatives that we have in our education, our basic education scenario. For example, there's no student textbooks on critical thinking. So in other words, whereas science or math or social studies, English language arts, there's a whole plethora of textbooks out there devoted to those academic domains. We want students to learn critical thinking, but we never set aside a time where we say we are going to teach them critical thinking. So there's no student textbooks. There's no college major in critical thinking for teachers. There's no state certification in teaching critical thinking. So it's not surprising that there's no standard curriculum for critical thinking, and there are no academic standards, no state or federal standards for teaching critical thinking, let alone assessing critical thinking. And so while we don't have a great deal of organized effort and formal effort in teaching critical thinking, we nonetheless believe that it is an essential component, if not the most essential component, of what we're trying to do in basic education. So that's just sort of setting the background to it. This morning I was at a talk on assessment. I believe it was in an Omaha school district. And they were talking about, following Common Core or NGSS standards and how this fits into designing assessments. And yet we're left with something like critical thinking with no formal assessment. So that's what we're going to sort of focus on today. And I think we're going to find out, I hope that we're going to see that we can incorporate critical thinking and assessment of critical thinking in across the entire curriculum. Although I would say that STEM subjects in science and math in particular are very, very good vehicles to deliver just general critical thinking to our students. Okay, so let's get started with all of that background. And let me just ask you a question. And that is, are you thinking right now? Okay, if you are sitting in your chair listening to me speak right now, I may have captivated you enough by our lead up so that you are focused on exactly what I'm talking about. But the question is, are you thinking right now as you walked into this lecture hall? Well, let's ask, if you were thinking at all, are you thinking critically? Well, the thing is that there is no doubt that you were thinking when you walked in here, but it's unlikely that you were thinking critically, because critical thinking is something that we do that is a specific, that requires specific control of our cognitive function. It's not something that we do by default. What we do by default is what has become known as a default mode network, or DMN. And this is what our brain does when a person is not focused on anything in particular in the outside world, when your brain is essentially at wakeful rest. You're not sleeping, but you're resting. It's essentially daydreaming or mind wandering. And this is where we spend a great deal of our time. And the elements of the default mode network are things like the neurological basis of self. So it's this autobiographical information about ourself, our self-reference, where we are in time, and reflections on our own state, our physical and our emotional state. It's also a time that we may be thinking about others, thinking of things that people have done, thinking about what other people are thinking, and pondering the emotions of others, how they feel about us, how they feel about the same situation that we're in. So we're not specifically working on a particular problem or trying to come up with a solution with this kind of thinking. It's kind of a wandering, remembering past and thinking about the future. So recalling past events, just thinking about your vacation, thinking of your drive in this morning, or envisioning future events. And I'm talking about if you're just sort of daydreaming about future events. If you actually get down to where you're making specific plans for future events, you're no longer in a default mode, but you're now starting to invoke some of the critical thinking skills that will sort of take you out of the default mode. So actually what I'm saying is, if we look on this slide and we plot and look at mental energy, or the amount of our mental energy that is devoted to thinking, we begin when we're not thinking about anything very specific in this default mode network that we talked about. However, as we shift from that daydreaming, mind-wandering state and start thinking about something specific, some sort of specific mental exercise like learning, we're trying to memorize something, critical thinking, and so forth, what happens is our energy shifts from that default daydreaming-like network to the more specific critical thinking related types of mental processing. Okay, so yes, when you're sitting here, you're talking and listening to me, hopefully you're shifting into more of a critical thinking mode, and your default memory network is being shut down to a certain extent. All right, so what do we want to cover today in this talk? there's really 3 points. We want to understand what we mean when we refer to critical thinking. And this is important in this particular talk because, as I said, I'm going to try to relate neurocognitive science to classroom practice. And what you're going to see is I'm going to make a case for why we should think of critical thinking as something called executive functions in neuropsychology. So that'll be an important part. The other thing that I want to do is I want us to develop a working understanding of executive functions after we've defined them and explained what executive functions are. And this is going to permit us to draw on a really massive amount of neurocognitive research with some really neat new technological tools that are available to neuroscientists when we consider applications of critical thinking in a classroom. Okay, so that if we're able to think of critical thinking in terms of the executive functions that are studied in neuropsychology, I think that'll be a tool for us to use in a classroom. And finally, I'd like to use this new understanding to promote and assess executive functions and critical thinking in our students. And so this is basically the 3 things that I would like to accomplish here today. But to begin with, I think that it's very clear that we have to address another issue. And that is that in order to critically think, we have to exert some sort of effort. We can't be lazy. And lazy brains, I use that term because I recall talking to a 5th grade student some years ago, and she was telling me that she really understood. I was visiting for our science, our LabLearner science program. I was visiting her classroom, and she told me that she really understood the science stuff, and she particularly was good in math. But she told me that it didn't make any difference because sometimes she just doesn't think. Sometimes she has lazy brains. And I thought, by golly, that's something that I think if we all were honest, we admit that we avoid thinking sometimes. Thinking is work. And so many times, even though we're capable of deep thoughts or critical thinking, unless we willingly engage in those mental activities, we don't necessarily come off as having thought things through very well. One of the things that I can point out that probably almost everybody can identify with are people that you know are well-educated, are intelligent, have accomplished things, still will do stupid things sometimes that you would be disappointed if a 2nd grader did or said what they did or said. And the point is that regardless of how smart we are, how intelligent we are, how accomplished we are, if we don't decide to use our brains, we can very easily fall back into that default mode where we're not critically thinking or using our executive functions. It turns out that, let's get to the point here. This is the organ that's responsible for thinking. This is the human brain. And the brain weighs about 1,400 grams or about 3 pounds. So if you think about it, that's about 2% of the body weight, of our body's weight. And yet, it uses about 20% of the body's oxygen consumption. That is, its energy. So 2% of our body's mass uses 20% of the energy that we expend. So obviously, this organ is doing something with a lot of energy. Interestingly, it's an organ that doesn't have any moving parts that we can see. Might not be surprising that muscles and hearts, respiratory, would use a lot of energy because of all the parts that are moving. And it's obvious that when muscles contract or when heart beats. But when you look at a brain, it's not moving. It's completely still, and yet it's burning up 20% of the energy in our body. And what can it do? It can think. And that's what the brain does, and that's what the energy used by the brain is used for. Now, There's a number of things that energy of the brain is used for. A lot of them have what we would think of as little to do with learning and memory or critically thinking. It's things like controlling our blood pressure, our balance, things along these lines. And they are even down to controlling hormone levels and things along these lines that we would think of as much more physiological than psychological in nature. Those things are, of course, going on all the time, and that is using up much of the energy that our brain does consume. The other thing for us educators that is more interesting is the effort that is put into the brain, expended by the brain, in the processing of information. And what we want to talk about now is something that is called the information processing model. And this isn't something that I can really spend a great deal of time talking about today. In a recent book, we talked about the information processing model in some great detail. In short, though, for our use today, information that comes into our brain is input from our senses, so we can hear, see, touch, taste things. And all the information that we have fed into our brain does come from our senses, of course. This information then is information that we select to focus on, enters into something called working memory or short-term memory. And it's important to know that most of the information that is taken in by our senses never makes it that far. There's something called a sensory register that filters out irrelevant information that would otherwise swamp our sensory system, and we wouldn't be able to think very clearly if we were concerned with every movement, every sound, every color that we come in contact with on a second-by-second basis. So our sensory register protects us from that being swamped by trivial information, so that only a certain amount of information makes it to where we're conscious and we're thinking about it. And let's just call that our working memory right now. And this is an important location when we talk about learning and memory. Information that is in our short-term memory is only there for a very short period of time, as the term short-term memory implies, but it also is very limited in its capacity. We cannot remember very many pieces of information in working memory. And working memory is called, I think the reason that it's called working memory is because it is a place where we are processing information. We are expending energy, sorting through, thinking through, trying to understand, trying to remember things that we have selected to think about in our working memory. We can forget information that's in our working memory and never have it available to us further unless it is processed in a way that leads to long-term memory. Long-term memory, we have no idea the time frame that we're talking about. It's probably lifetime memories. I think all of us as adults will remember things that 20, 30 years ago happened, and we had not thought about them for those 20 or 30 years, and yet we remember them. And that tells us that things that we have committed to long-term memory through the process that is shown on this slide are in there for a long period of time, if not forever. And that's not surprising, because ultimately, if we had more time, we would discuss the fact that in order for a long-term memory to be made, genes are turned on, proteins are synthesized, and structures called synapses between the brain cells, our neurons, are made. So there's actually a physical change that occurs in our brain that is the result of this learning and memory process. And that process is called consolidation. And consolidation is a very complex process that really involves, first we have to, as this illustration shows, first we have to attend to what we're thinking, Okay, so we have to focus on our our short-term memory system and our working memory. We have to retrieve information from our long-term memory and bring it into our working memory so that we can compare new information to things that we already know. Good teachers know this happens, and this is why teachers use analogies so often when teaching, so that you want to give an example of something new that a new concept, let's say, that you're trying to teach your students. You will reach them oftentimes by comparing it to something that they already know. Well, in order to compare new information that's being processed in working memory to old information, you have to retrieve it from long-term memory. So in the last book, we really focused on this concept of retrieval of information, that is referring back to what we already know when we are processing new information. We use that as sort of like the central theme of this last book called Brainstem. And this retrieval process we discussed as being very important in doing homework. You have to retrieve what you learned in school. And then homework is rehearsing. We're rehearsing information, we're retrieving it, and we're using it. And this leads to consolidation and long-term memory of information that we're processing in our working memory. Other thing that we discussed was the importance of group work. Whenever students discuss amongst each other what they are learning, they have to draw from what they have already learned about the topic to discuss it further. So discussion of the topic, discussion of concepts with student and within student groups is great for retrieval and rehearsal in the information processing model, thus leading to long-term memories and, in fact, learning. The other one example that we might cite for the importance of retrieval and rehearsal is family time. When we ask our child what they did in school today and they respond by saying nothing, then if we accept that, we are missing a tremendous opportunity to have that child go to their long-term memory, retrieve what it is that they talked about in school today, and explain it to you. And in the process, they are developing, the consolidation is taking place, and long-term memories are being made. We took this concept of referring to what you already know, to long-term memories, to process new information, and talked about how, as curriculum developers, we could build this into an overall multi-year curriculum that we refer to as a spiraling curriculum. But what I want to do now is I want to return to this information processing model and not talk so much about the retrieval part, but talk about something else that we didn't really discuss much in that book, and that is executive functions. Now, executive functions, we could have drawn it here, where we see over top of the information processing. There's got to be something that directs what we pay attention to, what we retrieve from long-term memory that we think is relevant to new information. What is it that controls this entire process? And this is what we call executive functions. And we've come to learn an awful lot about executive functions. And we're going to talk about that now for a bit. But just in general terms, executive functions oversees many, many other functions within the brain, and it sort of controls it, sets priorities. We're going to see that it helps make plans, it helps us execute plans. And there's a great deal of research on executive functions today. But in a very general sense, we might want to think of an analogy that executive functions is a lot like the conductor of an orchestra, that you have all these instruments, all these different pieces. But in order for those dozens of instruments to play together and to produce beautiful music, a conductor has to organize and control what the whole group is doing so that it comes out to be a event that it's focused, that all of the pieces are focusing on the same thing, and then we get the wonderful music that comes out. Now, executive functions, that ability to do that kind of orchestration of all the thoughts on our mind, is not something that we are born with a great capacity for. In fact, executive functions develops over time, over our time of our development in our lives. So in this graph, you see that we're plotting executive function skill proficiency against age along the x-axis. And what I would like to point out is that there's this really sharp increase that occurs between, let's say 3 and 5 or so, and point out that this is the time that is preschool or kindergarten. And so when we talk about the importance of preschool education, we can see that the executive function proficiency is increasing dramatically during that period of time that we have children in preschool programs. From there, executive functions do increase all the way through elementary school, adolescence, all the way through to adult, maybe about 30 years old or so. So what I've done on the bottom is just highlighted that really pretty much the entire time that executive functions are developing in the brain it's during that period that we are in school. If you go to graduate school or professional school, you may well be in school or doing additional training at 30. During that period of time, our executive functions continues to grow. And that is because our brain itself is developing during that same period of time. Executive functions occur in different places in the brain, but really focus in the very front part of the brain. And what you can see is that while the whole brain is maturing, as in these three drawings of the brain that you see over different times in development, if you look at it, it's red is least developed, yellow, greens, and blues lead to much more developed if you look at the development key here. So what you're seeing is that there are different parts of the brain that are developing at different speeds. The front part of the brain, or what we call the frontal lobe, you can see is becoming more blue between 3 or so and 5 or 6. That's during that very burst of growth that we see on the graph. And you see, though, that by adulthood, that the frontal lobe develops much more. So the point is that when we are born, our brain is not completely formed, and it continues to grow, and it doesn't. And the frontal lobe is actually the last part of our brain that matures, and that does not really happen until adolescence or so. So as a result, what's happening is that late middle school, even in high school, students are developing their executive functions. And one of the things that executive functions does is it helps you plan, it helps you execute your plans, but along with that, sometimes comes the independence that we may associate with adolescence. Prior to full development of the frontal lobe and the ability to make your own plans, you're pretty much going to go with the plans that your parents or guardians have for you. And as a result, adults, teachers, guardians sort of function as a child's executive functions early on, and as they mature, the executive functions start transferring to their own frontal lobes, and we take on. Now, go on in looking at executive functions in terms of learning and memory, it has a lot to do with how we make associations of our various senses. So in other words, if we look at very early development of a human, we have things like speech and smell, sound, touch, taste. We see things, we hear things, but we are not born knowing how those various sensations and perceptions are related to each other. What happens is our executive functions start coming into play, and we start relating things like smell to taste, or when you touch something, you can imagine what it looks like. None of that is inborn or hardwired. It is something that through our experience and guided by executive functions, we make these connections as we develop. If we look at an example just to show you that even though we set these associations very early in our lives, we carry them through our lives. And an example just to show you how this might work for one of the associations, let's look at speech and vision, how they are coupled by our executive functions by doing something together right now known as the Stroop test. And what we'll do here first is practice a Stroop test. And what you're going to do is you're going to see a series of words. And what I'd like you to do, and you can do this out loud, either here in a class or alone watching this webinar, you can, when you see a word appear on the screen, say the color of the text. So in other words, if you see the word red, you say red. You say red. If you see the word below it, house, you're still going to say red because the text is in red. Okay? So you're going to say the color of the text, not necessarily what the word says, but what the color of the text is. Here's an example. Red, yellow, blue, green, purple. Okay? So that's the idea. Now what I'd like you to do is do this on your own. There'll be about 10 words here. And just say the color of the text. Why don't you say it out loud? Okay. It's very interesting. I think that what you probably saw is that you would see a word that said B-L-U-E, but it was in red. You wanted to say red. You know you're supposed to say red, but you cannot help wanting to say blue because you are associating through your executive functions, your speech or language, and your vision. And there was a disjunct between those, and enough of this would give you a headache. Okay, again, what we were looking at was a paradox, essentially, that exists between what we were seeing and what color we saw and what word we read, essentially, in this particular case. If we look at the part of the brain that is involved, that becomes activated when we do a Stroop test, you can do this in a MRI, and we can look at which areas of the brain are actually functioning in real time during specific tasks. And this is a very powerful thing called functional MRI. And when you look at a functional MRI image of a individual that is doing a Stroop test, we see that this particular area here, highlighted in yellow, called the anterior cingulate cortex, lights up very reproducibly in people. And it's interesting because that anterior cingulate cortex lies in a position that has connections to the frontal lobe in the executive functioning and thinking, but it also has connections to an emotional center of the brain that we call the limbic system. So we're trying to rationalize what we're seeing, but it's having an effect on us also emotionally. And that's part of the unsettling, disquieting feel of when you do something like a Stroop test. And this really alerts your brain it's not a comfortable feeling. And a lot of teachers throughout the years have found that you can, anytime that a student sees new information or is presented with information that's contrary to what they already think or believe, that a paradox can form. And it's at that time of that paradox the brain is very alert, and teachers have used those moments to their advantage to get the children to learn new concepts and to discuss them in depth, bringing in not only their cognitive functions, but also tagging it with some emotional interactions as well. Okay, I was talking to some of my colleagues the other day and just threw out the idea and asked them, does information processing, does learning and memory still occur if we were to somehow delete executive functions? And it turns out probably it will still occur, but only memorizing. There's ways that you can memorize without having any real deep appreciation for the meaning of words. A spelling list, for example, you can memorize a spelling list without having much of a understanding of what the words mean. Now, this is something that I think that we can relate to a topic that teachers have learned for since the 50s in their various schools of education, and that is, on the right here, we see what is called Bloom's taxonomy, an updated version of Bloom's taxonomy. It used to be knowledge was at the base. Now it's called remembering. Instead of nouns of the old Bloom's taxonomy, this is all verbs. But the point is still the same. You begin with very shallow understanding when you just simply remember something. Your understanding and your ability to apply, analyze, evaluate, compare, and ultimately create new information or new things comes from moving up Bloom's taxonomy. And what I would like to say then here is that in many respects, moving up Bloom's taxonomy involves the application of executive functions. Okay, so let's get to asking the question of what is the difference or what is the relationship between critical thinking and executive functions. Now, critical thinking, we could pause and ask you to just shout out things that you believe are critical thinking or characteristics of critical thinking. I've simply listed some on the left here that I think you'll agree with. It's identifying problems, make predictions, analyze information, compare evidence, identify biases, infer or draw conclusions, determine relevance, apply information, and so on. Okay, these are specific things. Taken together, we tend to think that critical thinking is a good thing, but that won't do us much good if we are not able to break it down into more specific characteristics, which we're trying to do here. Okay, on the other hand, we have executive functions, and we'll go through these, but right now, executive functions that I will go through on a upcoming slide involves inhibition, shift, emotional control, initiation, working memory, planning and organization, and self-monitoring. And this is not necessarily a complete list either. But what my point is that we believe that critical thinking is essentially a subset of executive functions. Executive functions will go further than critical thinking, and you'll see how that is as why that is as we discuss this further. But right now, let's just say the critical thinking is essentially a subset of executive functions. And I think you'll see that. Keep this partial list of critical thinking attributes in mind as we discuss the 7 subdomains of executive functions that we're going to talk about beginning here. And we'll start with inhibition. Now, again, these are characteristics of executive functions, and these characteristics can actually be studied, and the location in the brain, which various components of executive function take, can actually be visualized in many cases by using paradigms that require their use while patients or subjects are in a fMRI situation. So inhibition is the ability to stop one's own behavior at an appropriate time, and that would include stopping both your actions and your thoughts. Okay, so inhibition, before you can think about something new, you're going to have to stop what you're currently thinking about. And that may not be easy. If you think about it, that may not be easy. Certain thoughts may be coming back to you and stopping you from shifting into a new thought pattern. Also, actions. You have to be able to stop certain actions and able to initiate new actions. And in fact, that leads us into shift, and that's the ability to shift from one situation or thought to the next. This is what gives us mental flexibility. We can, inability to shift, and we are going to be unable to be flexible as situations change. The other aspect of executive functions is emotional control, and this is the ability to use rational thought to modulate emotional responses. This is huge. One thing I may point out at this point for you to consider is that one of the reasons that these things, these steps in executive functions became interesting to me is because I was looking at the situation of ADHD, and students with ADHD are notorious for having reduced executive functions. And so they tend to be, it's hard for them to inhibit their actions, to shift from one situation to the next, and certainly to modulate their emotional responses. So keep that in mind, that ADHD is actually a condition that helps us define what executive functions is by some difficulties in that area. So we have inhibition, shift, emotional control, and also initiation. And this is the ability to independently generate ideas and solve problems. So you're really shifting. You have to inhibit one set of thoughts, shift to new ones, and then initiate problem solving. And here, with working memory, we get back to that entire information processing model of arrows, short-term, long-term memory, consolidation that we talked about previously. And this is the capacity to hold information in the mind in short-term memory for the purpose of completing a task or processing that information. Okay, so this is a huge part of executive functions, and a part that's very important to the actual cognitive steps in learning and memory. The next attribute of executive functions listed here is planning and organization. And this is the ability to manage current and future-oriented tasks. And we'll finish with looking at self-monitoring. And this is the ability to monitor one's own performance on a task. So in other words, something like reading. If you have read a short paragraph and you can ask yourself, did I understand that? And if the answer is no, what can I do about it? Well, I can go back and I can start rereading it until I get it, ask myself whether I got it. I'm self-monitoring, and I'm gauging my own cognitive performance. All these things taken together are what our executive functions do. So I think that if you see critical thinking now, those attributes of critical thinking, just look at how they are dependent upon all of these various executive functions in one way or the other. We can't think critically if we don't inhibit thoughts that we had before and shift to a new situation, a new problem that we want to solve. We have to be able to control our emotional response. We have to use our working memory. Ultimately, we have to monitor whether or not we're making cognitive progress. So all of these things are a component of executive functions. And that's why I would say that critical thinking depends completely on executive functions and is actually a subset of them. And let's move on to the next slide, because oftentimes educators, rather than thinking in terms of executive functions or even perhaps critical thinking, think in terms of intelligence. We know that with the Gardner development and thoughts theories from that had to do with multiple intelligences, different ways of learning, etc. What I'm going to do now is focus on two areas of intelligence, and there are others, but these are very important for our discussion as educators, and that is crystallized intelligence and something called fluid intelligence. Crystallized intelligence is the ability to use learned knowledge and experience. It has to do with the mastery of things like facts and figures, terms, rules, procedures. So these are intelligent. This is an intelligence that allows you to use specific knowledge that you have gained. On the other hand, there is something called fluid intelligence. And fluid intelligence is the ability to solve new problems and use logic in new situations, and even to identify new patterns. This has much more to do with things like problem solving, testing ideas, generating possibilities, planning steps, modeling situations, looking at cause and effect, recognizing cause-effect relationships. Okay? So it's not in any one particular area, or any one fact, or any one rule. It's being able to use whatever you need to draw upon, any of your experiences, any of your talents or skills, to be able to solve problems and do these other things. And we associate this with what's called fluid intelligence. It's associated with reasoning, and for that reason, it's associated with the information processing system and model that we talked about earlier for that is important for us in learning and memory. So returning to Bloom again, just to come back to that model, in a sense, if we look at and sort of place crystallized and fluid intelligence on this taxonomy pyramid, we would find that crystallized intelligence is more down in the memorizing or the remembering component of Bloom, with fluid intelligence increasing as we move up the taxonomy. Now, in the case of fluid intelligence, it's very much like, if you see in green here, if we plot fluid intelligence with age and development, we can see that fluid intelligence, very much like executive functions, is something that increases during childhood and adolescence and into adulthood, but then begins to decrease. And this decrease starts to kick in probably in the 30s, as roughly around 30 years old, as your executive functions are completing in their maturation. On the other hand, perhaps this is good news for some of the audience, crystallized intelligence doesn't seem to have this decrease associated with adulthood and old age, and continues to increase throughout our lives with experience and learning. Okay, so up to this point, as I said, the first part of this discussion was focused on more of the neurosurgeon's view of the brain, the neuroscientist, the neuropsychologist's view of the brain. And as promised, I want to shift our attention now and look more about the classroom view of the brain and how we can use some of this theoretical and cognitive research to help us in our teaching mission. First of all, if we think that executive functions and fluid intelligence and critical thinking are important, the question is, can we teach these things? Can we as teachers, can we as curriculum directors actually have an impact on executive functions, fluid intelligence? Or can we only give facts? Can we only give things to remember through memorization? Can we teach children to think? And I want to bring up a paper that was published a couple years ago in Intelligence, the journal Intelligence, by a couple colleagues of mine, David Baker at Penn State main campus, and Paul Esslinger, and I think they had some other colleagues on that paper. Paul Esslinger, that works with us at and is at the Hershey campus of Penn State College of Medicine. And this is an interesting subject, an interesting study that addresses the question, can we teach executive functions and increase in fluid intelligence in schools? And that's a very interesting question, but if you think about it, a very hard experiment to do, because what you would like to do is you would like to compare fluid intelligence of individuals that have gone through formal education compared to the fluid intelligence of individuals who did not receive formal education. And this is a question that has a lot of historical significance, and we could talk about all day. But what I like about this particular study is it did find a way to address this and do this difficult experiment. And in the process, what they ended up doing is they went to Peru and they worked with people in Peru where a large number of people are uneducated versus educated. And so they were able to have large enough test samples and samples that could be statistically compared between educated and non-educated populations. And of course, if you read the paper, they're going to control for many, many variables in it. I'm just presenting the results here. And what you see is up on the upper left, you see years of schooling. And it's from 0 to 18 years of schooling. And how is that correlated to fluid cognitive ability or fluid intelligence? And you see that the correlation is very high at 0.63. It's positive and it's very high. So in this study, they were able to show that formal education, classroom education, increases fluid intelligence. And the way they tested for fluid intelligence are these various neurocognitive analyses that you see at the top here. Verbal association fluency. This is the ability to group words together. Backward digits. A problem-solving analysis called the Tower test. Basic numeracy, mathematics, mathematical operations, and something called Raven's test, where you look for essentially nonverbal reasoning and look at complexity and looking at patterns. So none of these fluid intelligence assays, if you will, are dependent upon facts that you would have been taught in school. They're more to do with how you think, how you problem solve, how you make association, cause and effect relationships, pattern recognition, things that we would say were more controlled by executive functions, are more fluid in nature. So we see this correlation, and for all of these tests, all of these fluid association tests that are used, we know on the right-hand side that the frontal lobe is a major player in this type of fluid intelligence. These are things that we can see in the magnet as well. Okay, so there's things we would like to see these results reproduced in other situations. One of the problems that one may have, a critic may have of this particular study, is that I don't know how we are able to control perfectly for just the stimulation, the intellectual stimulation, somebody that's schooled versus unschooled. There's probably a lot of controls. The other thing I mentioned historically, if we go back one generation, two generations, certainly, we find that there is a lot of, a larger segment of, let's say, the American population that was not formally educated as we go back 50, 100, 150 years in this country. And yet, those without a formal education, people that never went past early elementary school, went on to make massive discoveries, great business leaders, inventors, lawyers, so on. And the relationship between schooling and executive function there is a very, very interesting question. And I just think that this is like some of the first evidence that we can see where formal schooling itself can improve executive functions and fluid intelligence. Okay, so how can we assess critical thinking? We'll get back to this concept of critical thinking. This is what we really want to do. Unless we can assess something, we have a very difficult time teaching it, because we can't find, it's difficult for us to tell what our impact is and adjust our teaching accordingly. So the question is, how can we assess critical thinking? And I'm going to give you an answer, but I think this is a very obvious answer that you probably would have come up with having never attended this session, and that is to give your students a constant supply of activities that require them to think critically in order to accomplish, and then see how they do. Now, this accomplishes two things. It gives the teacher something to assess. Okay, so that's the first thing. That's our point. We need to have some way to assess critical thinking. So essentially the scenario is that you assign some activity that it's very clear that you need to critically think to accomplish it. And then you assess or grade that activity. So now you've got your assessment. But what we would like to do is to take it, what we should really be thinking about is taking it one additional step, and that is to disaggregate that performance. And what I mean by that is when you have given them a critical thinking task to do, and then you grade how they did, you can look at their performance and break it down. Was there an issue? Did they not perform well because there was an issue with their reading of the question? Or was it that they read it correctly, but they have some fundamental problems with the mathematical operations or interpreting graphs or other things that led to them not performing well on a critical thinking task? It is this disaggregation that is going to ultimately be the most useful for us as educators, because we now have something specific. There's no point of assessing of showing children how to do interpreting of graphs if they have no problem with that, and their problem was basically just reading the question right. Okay, so one of the things that this obvious answer of how to assess critical thinking, that is give them something that requires critical thinking to do and then grading it, is the second advantage of it is that it provides students with practice in critical thinking. It doesn't make any difference what physical or mental skill that you want to develop, whether it be something like dance or sports or instruments or painting. regardless of what it is, the more you practice, the better you get at it. And we have to realize that's exactly the same thing with critical thinking. The same rule applies. The more we think critically, the more often we're put in situations where we have to think critically, the better we'll become at thinking critically. The better we will be at shifting from one topic to the next. The better we will be at inhibiting other thoughts that would negatively influence our critical thinking. The better we will be able to move through the information processing model to work and control our working memory. Okay, so the more practice in critical thinking, the better. Okay, now let's shift with that thought in mind. Let's shift to how critical thinking, how it can be assessed. What are some approaches? And I would like to go over just a few as we head towards the end of the presentation here. The first one is specific or special assessments, just that made up for assessing critical thinking. And the second one is critical thinking activities, things that students do, other academic areas or domains, and look for the participation of critical thinking in those activities. So rather than develop specific assessments for critical thinking, what we're going to do is look at components of critical thinking in other activities. We will then touch very briefly on hands-on science because this is an excellent area in which to develop critical thinking for students. And then the last one is prediction. It's not so much an approach to assessment as it is a kind of a sort of a hint or a tool that we can use to inspire critical thinking in the classroom. So let's go with specific assessments first. And here's an assessment. So in other words, this is an assessment in critical thinking. And this is an example for primary students, very young students, kindergarten, first grade, second grade maybe. And the idea here is you have two pictures, excuse me, and the questions ask, which one of these two pictures do you think was taken first? And why do you think that? So this may actually be given to students that cannot read the question themselves. The teacher would read the question, show the two pictures, and ask which one of these two pictures was taken first. And you can look at them, and most likely you will conclude that the picture that was taken first was the one on the right. And you may have reasons for that. One of the reasons is that the bowl of soup is emptying out on the one on the left, so obviously the picture on the right was taken first. If your students were to look at a picture like this and say, yeah, but what if they refilled the bowl? Well, that's fine. They're still thinking critically. The point here on these critical thinking examples is to get them to critically think and to give an answer so that you can see the quality of their critical thinking skills as they develop. Again, this is a primary example. These are easy to come up with. A critical thinking example for intermediate level, older children, is shown here. Here's a picture of a house in Michigan in the morning. And it's 8 o'clock in the morning in a cold November morning in Michigan. Overnight temperatures were very low and frost formed on the roof of the house shown here. You can still see the white frost on the roof. Use this picture to answer the following questions. Okay, so these are for intermediate students, 5th grade, let's say, 4th, 5th, even into 6th grade, middle school. And here's the question. As the sun continues to rise, in which direction do you think it is moving in relation to the house? From the left to the right in the picture? So in other words, it's moving from the left-hand side of the picture and cutting across to the right? Or is the sun moving from the right to the left of the picture? Okay? And then you have to explain why. And as you can if you look at this for a while, you'll see that the sun must be moving from the right-hand side of the picture towards the left-hand side of the picture. As it does, the shadow moves, the sun hits the frost, and melts as it moves across the roof.